Myself Sai Prasad, a lecturer in AhleBait High School and the Junior College. Welcome to a series of the lectures of 9th class maths. We have started a discussion with the chapter that is circles. What did we learn? We learned the basic theorem statements about chords and all other things, right? What do we learn about chords? Two equal chords, subtend, equal angles at the center, right? Like that, we have different proofs based on chords. Okay, let us discuss all those again. Now see here, the next question, he gave that there are two circles, they are intersecting at 2 points, let us say A and B. Then he is asking us to prove that their centers lie on a line which is perpendicular to the common chord. Okay, here AB is a common chord, then they are telling that PQ is bisected by this AB. Clear? Now look at this. How do we prove is, first let us consider triangle APO. Consider triangle APO and triangle BPO. Okay. If you observe here, AP is equal to BP, right? Yes or no? AP is equal to BP and OP is equal to OP, which is common side. Yes, fine. And not only that, we can tell that and AO equal to BO, because we have considered O as a midpoint, right? Fine. By these three things, we can tell that these both triangles, triangle APO is congruent to triangle BPO by SSS congruency. Is it clear? If they both are congruent, then their angles are also equal, right? That is, angle AOP plus angle BOP is equal to 180, right? Since these both are equal, what can we tell? Angle AOP plus angle AOP is equal to 180. Therefore, single AOP is equal to 90 degrees. It is perpendicular and bisecting. Clear? Similarly, we can prove this both, and we can even tell if they specifically ask whether it is bisecting, right? Did you understand? Fine. These are the basic few problems based on the theorems of chords. Let us have the statement of one more theorem, that is, the angle subtended by an arc at the center of circle. Let us say, for example, if this is an arc, okay, if this is some angle theta, okay, let us say some number, it is exactly double the angle subtended by any point of a circle. If this is theta, this will be 2 theta. Okay, the angle subtended by this arc is always double by the angle subtended by any point of the circle. It might be here, or it might be here, or it might be here. Okay, is it clear? Fine. For this thing, I can tell you one example, that what is the angle of a straight line? 180, right? What is the angle in a semicircle? Is always 90. Clear? What is the angle subtended here? 180. Is this double of this? Yes, right? Fine. Clear? Based on that, let us solve these two problems. What is given here? He is asking us to find the value of ADB. Clear? This is 100. We have to find this, and we have to find this. Okay? If this is 100, what about this? This will be 50. I am just writing, do not just get confused. If this is 100, this will be 50, because the angle ACB is half of angle AOB. Clear? That is why it is 50. Then what about this angle ADB? Just tell me. This is a cyclic quadrilateral. Then the sum of opposite angles in a cyclic quadrilateral is always supplementary. Remember, angles, opposite angles in a cyclic quadrilateral are supplementary. Okay, that is, angle ADB is equal to 180 minus 50, that is 130 degrees. Clear? Fine. Similarly, see this next question, he is asking us to find BCD, it seems. Just have a tell what is the answer? Obviously that is 40. How? This is equal to this is equal to this, right, and obviously these are vertically opposite angles. So, they are making equal angles at the center, therefore, these both are also equal, both the triangles are congruent to each other. So, except these two angles, these remaining all other angles will be, I mean it is BCD, right, BCD or OCD both are 40, clear? Did you understand? You have to prove that, fine. Nice. Shall we move on to the next problem? Let's do. Look at the next question here. He is telling OM is 3 centimeters, AB is 8 centimeters. Then he is asking us to find the radius. Okay. Now tell me, the distance from center to chord is always a perpendicular. So this is a perpendicular. Okay. If I join OB, now tell me what is OMB? It is a right angle triangle. He is telling that this AB is 8, then this will be 4 centimeter and this height is 3 centimeter. Can I find this OB? How do I find? By Pythagorean theorem. That is, I can find OB square as 3 square plus 4 square, that is 9 plus 16, which is 25. OB is equal to 5 centimeters. Therefore, radius is 5 centimeter. Clear? Isn't it? Fine. Next, see here. If BD equal to 4 centimeters, then find the radius of a circle at some. Just have a look. Here, BD is 4 centimeters. That is, it is a diagonal for this square, right? Yes or no? This is diagonal. What about the diagonals of a square? They are equal to each other. Therefore, this diagonal is equal to this diagonal, which is nothing but radius of a circle, isn't it? Therefore, radius of a circle is 4 centimeter, because the diagonals of a square are always equal to each other, right? Next, he is asking us to find the angles of OCD. How do we find? Just you people know very well. If this is 70, this is also 70. This is a isosceles triangle. Therefore, angle C plus angle D plus 70 is equal to 180. Both are equal. Let us say they are x. 2x is equal to 110. Therefore, x is 55. Right? Both the angles are 55 and one more angle is 70. Right? Fine. Next, see here. He is asking us to find the x and y of this both the figures. Here it is a cyclic quadrilateral, then the sum of two opposite angles of a cyclic quadrilateral is always complementary, I mean supplementary. Therefore, x plus 110 is equal to 180. Therefore, x will be 70. What about this? Y plus 85 is 180. Therefore, y will be 95. Yes or no? Fine. Here this is a diameter, okay, then what is the angle in a semicircle? 90. Therefore, the angle of x is 90. What about y? The sum of remaining two will be 90. Therefore, y plus 50 is 90, y is equal to 40 degrees. Clear? This question easy. Shall we move on to the next problem? Let's do. Look at these problems. These are very important and very useful theorems. That is, if a parallelogram is cyclic, then he is asking that prove that it is a rectangle. How do we do? Tell me. Let us consider some parallelogram inside a circle A, B, C, D. Okay. He is clearly telling that it is a parallelogram. Obviously, opposite sides are equal. Yes. Then he is telling that it is a rectangle it seems. How do we prove? First, see here, let us prove that both the triangles are congruent. How? These both will be parallel and equal, and these both will be parallel and equal, and the middle line is common. Yes, and not only that, we know that it divides both the triangles into two equal halves. So, their dimensions are equal, right? And the opposite angles of a quadrilateral are supplementary. Therefore, this plus this is 180. Since both are equal, they are 90. Okay, opposite sides are equal and all the angles are 90. What is it? It is a rectangle. That is what we are going to do now. See here. Consider triangles ADC and triangle ABC. Okay, just equate them. AB is equal to CD and the next BC is equal to AD, right, and AC equal to AC, that is common. Therefore, triangle ADC is congruent to triangle ABC. Clear? Therefore, by CPCT can I equate angle D is equal to angle B? Yes. Now, what is opposite angles of a cyclic quadrilateral? They are always supplementary. Therefore, angle D plus angle B is equal to 180. Since they both are equal, each angle is 90 degrees. Similarly, remaining all 4 angles also will be 90. Clear? Therefore, cyclic parallelogram is a rectangle, right. Next, see the next question. Prove that cyclic rhombus is a square. Just tell me. Let us consider a circle, a rhombus, okay. Fine. Now tell me, rhombus means the same, opposite sides are equal. Fine. Then what about the angles? Angles, here the same thing. Let us prove these two. Okay. Rhombus, their vertex angles are not 90. So let us prove it as 90. Let us consider ABCD is a rhombus. Then see here, consider two triangles, that is triangle, let us say ADC and triangle ABC. Okay. The same thing it follows, that is AD is equal to BC, and not only that, CD is also equal to AB, isn't it? Obviously, all 4 sides are equal. Clear? And AC equal to AC, that is common. Therefore, triangle ADC is congruent to triangle ABC by SSS congruency. Therefore, by CPCT I can equate angle ADC is equal to angle ABC. Yes. Now tell me, angle D plus angle B is equal to 180. Since it is cyclic quadrilateral, the opposite angles will be in supplementary. Therefore, D plus D is equal to 180. Therefore, D will be 90 degrees. Clear? Therefore, cyclic rhombus is a square. Clear? Is it not easy to remember? Fine. By this problem we can end the chapter, that is circles. What all we learned in this chapter? We started with the basic definition of circles. Then we learned a few basics such as chord, secant and all other things. Then we did few theorems of chord, okay, and then we did construction, and then we did a few theorems based on the properties of a circle with respect to chord and everything. Clear? Fine. Hope everything is clear for you. Let us meet in the next session with a new chapter of 9th class. Thank you.